So here is that substantia nigra down here, sort of in the midbrain, and it's this nucleus which then projects up all across and says dopamine all throughout the brain, which then changes the dynamics of the neurons. And cocaine is a drug which actually blocks the reuptake of dopamine. So a lot of neurotransmitters are actually actively degraded by enzymes, and some of them are just reabsorbed by active pumping. And cocaine is a drug that actually blocks the reuptake of dopamine and allows it to linger around, giving you this dopamine. Dopamine is released by the body when you, as a reward system. So you're doing something. For example, you get a reward, you get some sugar water, and then you have to press a lever to get that sugar water. Well, the first time you get that sugar water, you get a huge spike of dopamine. And then if you realize that you had to press the lever to get that sugar water, then as soon as you press the lever, you get a huge spike of dopamine. And if you don't get the sugar water following that press of the lever, you find you actually have a huge drop in dopamine. You feel like crap. And so it's a sort of both a positive and a negative feedback. And interestingly enough, the dopamine boost you get goes back to earlier and earlier and earlier to the earliest event that can be associated with that award. So it just keeps moving earlier and earlier. And so taking cocaine gives you that reward. It's interesting that the faster you can get that dopamine effect, actually the higher the reward you get. So the rate of onset's really important. And so there's other drugs like methamphetamines which actually cause a dopamine release. And then your body recognizes, oh, well, I have these dopamine receptors, and now it starts downregulating the dopamine receptors. So then when you stop taking the drug, well, then you feel terrible because you're losing sort of the stable, steady state of positive feedback that sort of the good feeling that you have. So then you go back to taking the drug, and it becomes a really negative cycle. Here's the noradrenergic system, locus coeruleus. This is involved in, so it's norepinephrine that's being released from here, and it's involved in attention and arousal and changes dramatically during sleep-wake cycles. It's also involved in learning and memory. So when you have a very emotional response to something, you'll get a big norepinephrine to help stabilize that memory that's there. If you recall flashbulb memories, have you had that where you hear about something big and everybody, like, where were you when 9/11 hit? So, does everybody remember where they were when 9/11, they first heard the news of 9/11? Yeah, I mean, that's called a flashbulb memory, and that's, so now here's now we're looking down into the medulla, so deep down into the brain here. Did I go forward? So now, there you can see the medullary pyramid. So that's going from the brains to the spinal cord. And then right along the center here, this is the medial lemniscus. Those are all those nerves that are coming up from the spinal cord, up. So medial meaning the center. You have the olive, which is involved in auditory. Raphe nucleus, which is a nucleus which, when it's active, actually sort of disconnects your body from your brain so that when you are sleeping and you imagine something, you don't actually walk around. You find patients who find themselves, I hear a story of somebody who woke up and found himself sitting on top of a bookshelf in his living room and acting out his dreams and beating up a significant other, which, they realized he had to actually tie himself in a sleeping bag so that he couldn't act out his dreams. Really frightening stuff. So here is going the opposite direction. So once again, now that we have this pathway, so the spinal cord comes in through the dorsal root. So that sensory comes in. It goes back up through the dorsal horn and up through that nucleus, the either gracile or cuneate fasciculus, up to the gracile or cuneate nucleus, and then through the spinal decussation, and into the medial lemniscus, and then up into the ventral posterior lateral nucleus of the thalamus. and up into the motor cortex. So here's acetylcholine. These are also involved. There's this big nucleus here in the brain, and this is also involved with sleep-wake cycles and memory and learning. I mean, it gets really... These are also involved in so many different things, it's hard to just nail it down to one thing. But acetylcholine depletion in Alzheimer's is seen a lot. And then here's the serotonergic system, which you hear about. So 5-hydroxytryptophan is serotonin. And so we talk about tryptophan that people eat during turkey dinner. It turns out the amount of tryptophan that actually gets across the blood-brain barrier is really, really small. Really what you're seeing following a turkey dinner is your body's response to a big turkey, and you're seeing the parasympathetic response going, let's sleep now, and not really the tryptophan. But, you know, you've heard about the tryptophan. LSD is a drug which actually changes the serotonergic system, acts as a serotonergic agonist, which acts like serotonin. And then some people who are depressed are treated with SSRIs, which is a serotonin reuptake inhibitory system. So it actually allows the serotonin to stay in the synapse longer